Good evening, class. We are looking at College Algebra Chapter 2, Equations and Inequalities. Here's Section 2.1, the rectangular coordinate systems and graphs. The rectangular coordinate systems and graphs. So in this chapter, we are going to cover the rectangular coordinate systems and graphs, linear equations in one variable, models and applications, complex numbers, quadratic equations, other types of equations, linear inequalities, and absolute value inequalities. So let's start with the rectangular coordinate systems and graphs, X, Y plane, plotting points, quadrants, and so forth. So rectangular coordinates in a two-dimensional rectangular coordinates, okay? Or when you look at this, I hope it comes to mind, this is also known as Cartesian coordinate system. A horizontal line is called the x-axis. Vertical line is called the y-axis. The point of intersection of these axes is called this point, the origin. Upon intersection of the horizontal and vertical axis, we get 4 quadrants. So these are the answers. Cartesian coordinate system, x-axis, y-axis, and 4 quadrants. Determine if the following points are on the graph of this function, this equation, minus 3x plus y equals 6. 0, 4. Simply put, plug in and observe. Replace the x with 0, y with 4. We get 4, which is not equal to 6. The answer is no. This is not. Let's plug in minus 2, 0. That works because this is positive 6, this is positive. This works. This one doesn't. When we plug in negative 1 and 3, that works also. And we can plot those and come up with the graph. Meaning negative 2, 0, which is also known as an x-intercept, and negative 1, 1 to the left, 3, 3 up, and put them together. Graph equations by plotting points. Y is 2x plus 5. So all you have to do, pick up something. Let's say x is 1, you get 7. X is 2, you get 9. But what about x is 0, you get 5. Okay, and so forth. Just pick up some points. If you plug in minus 5, you get minus 5, 0, 5, 10, 25, 1, 7. Now, the most important parts are actually this one, which is the y-intercept. And now this one. It says, what if y is 0? If you set y equal to 0, you can move the 5, and you get minus 5 divided by 2 equals x. Okay, negative 5 halves. 0, and if you plot those pairs or sum of them, for example, the main ones again, or the intercepts 0, 5, negative 5 halves, 0, and connect them. Y equals x squared, you probably remember it from a previous algebra courses. This is a parabola that opens up, so if you plug in 1, you get 1, 2, you get 4, 3, you get 9. If you put negative 1, also you get positive 1. If you put negative 2, also you get positive 4, negative 3, you get positive 9. And so 0 gives you 0. And so those are the pairs. These are easy ones, of course. And if you plot them carefully, it looks like a parabola that was mentioned before. Find the intercepts from a graph and an equation. The x-intercept is the point at which a graph crosses the x-axis, has the coordinates x, 0. The y-intercept is the point at which the graph crosses the y-axis, 0, y. Example 4, find the x-intercepts and the y-intercepts of the graph of y equals x squared minus 4, then graph by plotting points. If I want to find the x-intercepts, I set the y equal to 0. If I want the y-intercepts, I set the x equal to 0. So if I set y equal to 0, y equal to 0, x squared equals 4, x is plus minus 2, and that means negative 2, 0, as well as 2, 0. That gives us two pairs. Now, the y-intercept is easy in this case. Basically, if you set this one equal to 0, you get minus 4. So that should be an easy pick. And so you pick up more points if need be, such as just make one up. If you put negative 3 squared, you get positive 9, minus 4 is 5. If you put negative 1, you square it, positive 1 minus 4 is negative 3. And of course, those three intercepts, we put them all together. We have the graph. Needless to say, later on, we will look at various methodologies and better ways to graph things. Reminding you of the formula you probably remember, known as the distance formula. If you have one point with coordinates x sub 1 and y sub 1, and one point with the coordinates of x sub 2 and y sub 2, and you want to find this distance, or these d of p1, p2, the formula is square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. The distance d between 2 points with coordinates x sub 1, y sub 1, and x sub 2, y sub 2 can be found as follows, which is simply using Pythagorean theorem. If you call this A, B, C, you recall a squared plus b squared equals c squared, known as Pythagorean theorem. So this distance, square it. What is this distance? X sub 2 minus x sub 1 in an absolute value. This distance, or b, is y sub 2 minus y sub 1 in absolute value. And you square that according to this, a squared plus b squared equals c squared. Or c is the square root of a squared plus b squared, which is this formula. And so that's being raised to the power of 2 x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. The reason we can use the parentheses instead of an absolute value is because when you raise this to the power of 2, regardless, it becomes positive. Okay? And so we say the distance as this formula. The reason we use an absolute value here, because we may not know which one is at, we are generalizing. Which one is at top, which one is at the bottom, whether in this case, clearly y sub 2 is larger, but it may be smaller. That's why we put in an absolute value, but when we square it, it makes no difference. And because it makes no difference in that sense, even if you put x sub 1 minus x sub 2, Makes no difference when you square it. We want to find the distance between these two pairs. One has coordinates 1, 3, one has coordinates 5, 6, and according to this one, x sub 2 minus x sub 1, we can write it in this fashion. And y sub 2 minus y sub 1. This distance is x sub 1, 5 minus 1, or 1 minus 5 in an absolute value. This distance, 6 minus 3 or 3 minus 6 in an absolute value. And you square it, or simply put like so. 4 squared and 3 squared is 25. The distance becomes 5. Everybody knows that. So if we wanted to show it with the graph, but without having the graph, we are given two pairs. We want to find the distance between 2 comma negative 4 and negative 1 comma 3. So according to this formula, everybody, the square root of x sub 2 minus x sub 1 minus 1 minus 2 quantity squared plus y sub 2 minus y sub 1, 3 minus negative 4 quantity squared. Minus 1 minus 2 is negative 3. And 3 minus minus 4, 3 plus 4 is 7. Again, it doesn't matter negative or positive because you're going to square this and you're going to get 9. You're going to square this and you're going to get 49. They add up to 58. This is the precise answer. So exact answer, everybody. If you put it into a calculator with a bunch of decimals, 7.62 is an approximation. Plot these points. A has coordinates negative 2 comma 1. B has coordinates 2 comma 3, and C has coordinates 3 comma 1. So let me fix that because we don't want to make a mistake. So I'm assuming nobody has any problem, plotting points. So we plot them. This creates a triangular shape, A, B, C. So we have that. So plot them, form that. We want to find the length of each side using the distance formula. For example, if I want AB, the distance between A and B, using this formula, 2 minus negative 2 quantity squared plus 3 minus 1 quantity squared. This is 2 plus 2, 4. 3 minus 1 is 2. 4 squared is 16. 2 squared is 4. They add up to 20. And you may recall that 20 is 4 times 5, so the 4 comes out as 2 squared of 5. This is exact answer. I want to keep it as an exact answer. So the next one, let's say we want to find this distance, x sub 2 minus x sub 1. Okay. Whether I say 2 minus 3 or 3 minus 2, it doesn't make any difference. I'm going to square it. Plus, whether I say 3 minus 1 or 1 minus 3 makes no difference. I'm going to square it, but I'm going to keep it consistent. If I say 3 minus 2, then I'm going to say 1 minus 3. 3 minus 2, that means 1 square it. 1 minus 3, that means negative 2 square it. So this is 1, this is -2. When you square the first one, you get 1. When you square the next one, you get 4. They add up to 5. Square root of 5 precisely. Finding the distance between A and C. You can go through the process, or you may see that because the y coordinates are identical, 3 minus -2, that means the different distance of 5. If you go through this process, okay, 3 minus -2 quantity squared plus 1 minus 1 quantity squared, it gives you the same answer, 5. Or simply put, since they have the same y coordinates, this distance would be 3 minus -2, which is +5. So we found the first part. The second part, is this a right triangle? Well, you remember the right triangle, a squared plus b squared equals c squared according to the Pythagorean theorem. And so let's square the sides, see if it works out. So ab squared plus bc squared. We're going to square this. When we square this, this becomes squared becomes 4, and this comes out as 5. Okay, 4 times 5, 20, plus 5 is 25. And as you know, the other side, AC squared is also 5 squared is 25. And this is a proof that, yes, this is a right triangle. Find the area. Whenever you have a right triangle, the sides, one of them is the base, one of them is the height. Remember, the area is 1/2 base times the height. So 1/2 this side times this side. Square root of 5 times 2 square root of 5. I hope you realize the 2 cancels this one. Square root of 5 and 5. Let me just show you just this one. Cancels out this one. The product of these two is simply 5. And you're done. I want to quickly remind you of something else. For a method of finding area of a triangle, okay, from its sides, this one was a right triangle, it made it easy. But if it's not, from the sides, we can use what's called Heron's formula. Comes from 2,000 years ago. First, you calculate S, which is half of the triangle's perimeter or semi-perimeter. That's why they call it S. A plus B plus C divided by 2. Add up the sides, divide by 2. And then calculate the area as the square root of S times S minus A times S minus B times S minus C. In case, and I don't know if you have seen this formula, I think you have before, but if you haven't, that'd be interesting to see. To find the midpoint, in short, it says find the midpoint of the line segment from P1, which has coordinates 4, -2, to P2, which has coordinates 2, -5, and plot the points. And the midpoints, it's pretty straightforward. You plot those points and you pinpoint the one in between. Now, the formula for the midpoint is that you add them up, you divide by size. What do we add up? We add up the x coordinates, we add up the y coordinates, and divide by 2. Okay. And to show that just quickly, if we take the line segment P1, P2 with the midpoint M, so we pick up the middle of this, right here. We can draw all of the blue lines, and then this one and this one are parallel to the x-axis. This one and this one are parallel to the y-axis. All vertical lines are parallel, and all horizontal lines are parallel lines. And it gives us congruent pairs such that these angles are equal. Okay, angle 1 and 3 is equal, 2 and 4 equal. This is 90 degrees. This is 90 degrees. The two are become identical. The two triangles. Why are they identical? Because all the angles are equal, and one side is equal. Remember, we are looking at the midpoint. So this distance is identical to this distance. In other words, P1M equals MP, P2 or P2M. Okay, if we want to write this, we can write it in this fashion, that let's write MP1 equals MP2. This is by the definition of a midpoint. We have chosen the point in such a manner. So with that being the case, if we look at this distance then, which again, what are the coordinates for the midpoint? We don't know. We're going to call them x and y. What are the coordinates for this point? We know it's x sub 1 and y sub 1. What about this one, x sub 2 and y sub 2? We want to figure out what is x, what is y. We know this distance is equal to this distance. In other words, this distance, which is x minus x sub 1, is the same as this distance, which is x sub 2 minus x. So they are equal. And if I move this, becomes plus x here. Move this becomes plus x sub 1. And so if I divide both sides by 2, that's exactly what I have for x. And I can do the same thing for the y coordinates. This distance, y minus y1 is the same as this distance, y sub 2 minus y1. And if I move things around, this one becomes plus y1. This one becomes plus y. We have this one divide by 2, and therefore we have y, and here's the midpoint. So for, again, I don't ask you to prove the midpoint or the distance formula, but it's good to know the proof. So how do you find the midpoint? Now add up 4 and 2 divided by 2. 4 plus 2 divided by 2 gives us 3. Add up the y coordinates, negative 2, negative 5. We get negative 7 divided by 2. And therefore, the midpoint has coordinates 3 minus 7 halves. I'm going to leave it for you to plot this pair, and this pair. Okay, make sure you plot those pairs on your own class. Okay, so we can move on. Plot the following: 0, 3, 1, 3, minus 2, 3, 1, 3, and minus 4, 3. All of them, notice they have the same y coordinates. How would you describe this set or any set like that? A number that has a fixed y value. So if you plot those pairs, they all have the same y coordinate. The points must be on a horizontal line that is 3 units above the x-axis. Later on, we discussed that. I hope you remember that from algebra before, that this has the equation y equals 3, and slope for any horizontal line is 0. It's an interesting question. Let's quickly look at it. We want to find the points with y coordinates of minus 6, whose distance from the point 1, 2 is 17. And we want to use two different methods. We want to use Pythagorean theorem, and you want to use the distance formula. Let's see how we tackle that. So here's a rectangular coordinate system. Here's the pair 1, 2 located somewhere here. Okay, 1 to the right, 2 up. We want to find the point with the y coordinate of minus 6. So this is 1, 2, 3, 4, 5, 6 below. So somewhere here, that's the idea. So here's the line y equals minus 6. Okay. So the point we are looking for belongs to this line. Is it here, 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 here? We may not know that. But that's the concept. happen to be 2 points, and we can see why in a moment. But somewhere, if we draw this, these two are identical, okay? So we have some point here and some point here. We want to locate them using Pythagorean theorem. So if we use the right triangle, the hypotenuse, this one or that one doesn't matter. The hypotenuse is 17. Why is that? Because it says so. Find the points with y coordinates of -6, whose distance from the point 1, 2 is 17. So we know this distance is 17, it says so. So what is this distance? What is this distance? Well, we may not know it, or we may be able to figure it out. So if we look at this distance, we don't know. But what about this distance? If this is 6 down, this is another 2 up, total distance of 8. So this leg must be 8. So one leg is this 6 plus this 2, because it's looking at 2, right? The y coordinate. So this distance must be 8. Okay. So if it's 8, so a squared plus b squared equals c squared. Let's plug in. So this is 8. This distance or this distance doesn't matter, is b. And this is 17. And we're going to use Pythagorean theorem. So therefore, 8 squared plus b squared is 17 squared. So b squared is 17 squared minus 8 squared becomes 225, and b becomes 15. I'm going to assume we can use a calculator quickly to figure out what happens. If this distance, again, this may not be too scary. If this distance is 15, we should know that this has coordinates. Let's just actually put it in there, 1 minus 6, right? This one has the same x coordinate as this one, has the same y coordinate as the line. So if this is 1 minus 6, and this is the distance of 15, so when we go to the right, 1 and 15 will give us 16. So 16 minus 6. From 1 go to the left by 15. 1 minus 15 puts us at negative 14 minus 6. So those. So 1 minus 15, negative 14 minus 6, and 1 plus 15, 16 minus 6. So we can do it this way. That's part A. And for part B, we can use the distance formula. And we are going to say that the coordinates are x. We don't know the coordinates. It's going to be x and minus 6. And we're going to use the distance formula. X sub 2 minus x sub 1, we're going to say x minus 1 quantity squared plus y sub 2 minus y sub 1. Okay, so we can say 2 minus minus 6 or minus 6 minus 2 quantity squared. It doesn't make any difference. Okay, so we are going to say 1 minus x quantity squared plus 2 minus minus 6 quantity squared. Now this is going to be squared as 1 minus 2x plus x squared. This is positive 6, adds up to 8 and becomes 8 squared or 64. With this one becomes 65. So x squared, square root of x squared minus 2x plus 65 is 17. Now, this is the equation we want to solve. If we square both sides, this becomes x squared minus 2x plus 65. Let me just use this. So if I square this, it just comes out. If I square this, I get 289. I'm going to move this and subtract it from 65, and I get minus 224. And I can factor this, or I can use the quadratic formula, and I get x plus 14 times x minus 16. And that's the factored form. X is either negative 14 or positive 16. We discuss factoring further later on, although you have seen some basic ones. And that gives you the same answer as here, because x is minus 14 or x is positive 16. And the y coordinate was fixed at negative 6. We have the same answer as here. Find the midpoint of the line segment P sub 1 having coordinates negative 5 and 5 to P sub 2 having coordinates 3, 1. Plot the points and their midpoints. And so the formula is very simple. Add up the x coordinates, minus 5 and 3 divided by 2. And we get negative 1. We add up their y coordinates 5 and 1, we get 6 divided by 2 is 3. And the midpoint has coordinates negative 1, 3. We can plot P sub 1, P sub 2, P sub 3, put them all together. Finally, I want to mention graphing equations with a graphing utility. Most graphing calculators require similar techniques to graph an equation. The equations sometimes have to be manipulated so they are written in the style of y equals. In other words, you have to solve for y. The TI-84 Plus and many other calculators, makes and models have a mode function which allows the window, the screen for viewing the graph, to be altered so the pertinent parts of the graph can be seen. Here's an example. Y equals 3x minus 5 is all fine. However, y equals 2x minus 20 cannot be seen on the screen where the graph crosses the axis. The standard window screen on the TI is minus 10x less than or equal to x less than or equal to 10. It's basically the x is between negative 10 and 10, y is between negative 10 and 10. And if you plot this, y1 equals 3x minus 5, it looks decent. It shows everything. It shows the intercepts. But if you plot 2x minus 20, a lot of things are missing, because the windows normally have they go minimum x value from negative 10 to 10. The y minimum happens to be the same. So what I want you to do, by changing the windows to show more of the positive x-axis and the more of the negative y-axis, we have a much better view of the graph and x and y coordinates. I highly recommend you try this, everybody. Okay.